Hello, I'm Fran Zandanella Benjamin, founder of the Pipeline Conference, and I just want to welcome you to our event on part two, integrating AI and ML into VFX animation and games studio pipelines. I want to tell you first, before we get started, that we have a new organization that's over the Pipeline Conference, and it's called the Digital Production Pipeline Association, DPPA. So you can check out our website to learn more, and I'll post it about it in the chat. It's pipedev.org, so super easy to get to. And we also have a Discord channel for people to talk in between these types of events. We're building our community, and I'm super excited about that. Um, I would like to welcome our executive host, Eric Shamblin. And Eric, if you want to say a few words about yourself.
Sure. Thanks, Fran. Hi, everyone. Yeah, my name is Eric Shamlin. I'm a 30-year veteran of producing across many mediums. Worked in visual effects for a long time. Now run an AI animation studio. I'm on the board of governors for the Emmys, and with that, I chair their AI task force. So I've become a vocal member of the TV community in how and when and why we adopt AI into our pipelines. And so it's a real honor to join such an esteemed group here and help moderate this panel. And with that, I'll tee it off. We're really glad you all could join us today for part two of the AI, ML, and VFX Animation and Game Studios Pipeline series here at the conference. First, a big thank you to Fran and her organizers for inviting us back to continue this important conversation. These events take a lot of work and vision, and so we're grateful to be part of it. We're all pioneers here, not just us speaking and presenting today, but I think likely everyone on the call. This is still new territory for our industry, and it's exciting, but also daunting. It's daunting to be shaping how AI and machine learning will transform creative pipelines for decades to come. It's a big challenge. There's a lot of skepticism, a lot of conversation, and I think there'll be a lot of learnings today. Before we dive in, though, just a quick reminder, please keep your cameras off throughout the session. And if you have questions, please drop them into the chat. We'll be saving them for the end of the call or the end of the Zoom after the main presentations. And then for best viewing, we recommend, I believe, gallery mode or speaker mode. And with that said, in part one of the series, we explored the nest and crawl phases. That was the fundamentals of machine learning, how to set strategy, and how to build early momentum. That session is available on YouTube. If you've missed it, I will drop the link here. I've got it for those that like it. And today, in part two, we're shifting into high gear. We'll be exploring the walk and run phases, where AI moves from promising proof of concept to scalable, production-ready solutions that deliver real creative and business impact. We'll also spend time on the most overlooked, but absolutely mission-critical topics in creative AI, and that's data as fuel. Models often get the spotlight, but it's the data sets behind them that really power the results. And so with that set up, I'm thrilled to announce and introduce our two expert presenters. First up will be Christine Middlemiss. With over 20 years in innovation and software development, Christine has held key roles at IBM, Autodesk, Rockstar Games, and DreamWorks Animation. She was also the CTO at Mars VFX, where she drove major advancements in cloud infrastructure, rendering pipelines, and led the creation of groundbreaking AI products like Vanity AI and LipDub AI. She's currently the manager of software development at Infotech Research Group, where she leads development teams and data-driven platforms. She will then be followed by Ishrat Badami. Ishrat holds a master's in computer vision and machine learning from the University of Bonn. She worked as a researcher, contributed to the EU's STRADS project on mobile assisted robots, and built AI-driven solutions in healthcare, visual effects, and ad tech. As an early member of the Vanity AI team at Mars VFX, she helped pioneer AI solutions in visual effects. She now consults full-time, delivering ML and computer vision solutions across industries. And with that said, I'm going to hand it off. We have a lot to cover. I believe we've got nearly an hour of presentations lined up for you. And again, if you've got questions, please share them in the chat. We'll collect them and answer them at the end. And with that, let's get started. Christine, if you'd like to take it away.
Perfect. Thank you so much, Eric. I really appreciate that. Okay, so let's get started. So welcome back, everyone. Today we are going to, as Eric said, we're going to be continuing with part 2 of our AI product development framework. So where we left off on part 1 was I had challenged you for 3 days to try AI. So I wanted you to explore existing AI tools, and that goal was to sort of become more comfortable experimenting and see firsthand how AI can enhance creativity, um, pro productivity, problem solving, all those things. I wanted you to kind of have that aha moment because I think sometimes, when I talk friends, family, coworkers, like there's this like, I don't know still. And so I hope you were able to do that and you enjoyed the challenge. I will not, I had a little bit about covering the part 1, which is perfect because Eric covered it. So you can see the link there on for the YouTube channel. So again, today we're going to be focusing on walk and run, those phases that take AI from proof of concept to production ready, scalable solutions. We're going to look at the structured workflows. We're going to look at optimized infrastructure and continuous improvement practices that ensure the reliability and adaptability at scale. So then, as Eric said, Ishrat is just going to cover the 3 pillars of AI that carry into AI production. Okay, so data as fuel, evaluation metrics, and model architecture. So whether you're scaling your first AI project or just boosting your existing workflows, today's session focuses on turning promising experiments into indispensable production tools for VFX, animation, and game studios. Okay, so I did want to show this slide that I had shown in part 1 last year, which is just the overview of the 4 phases. Okay, so we had our nest and phase, our nest and crawl that we did before, and now we are going to talk about walk and run. So walk is, I want everyone to kind of get sort of, I have 2 words, 1 word for each of these. So for my word for walk is discipline. So it's the development and iteration phase. Its core features are implemented, tested, and refined based on feedback that you receive. And then the word that represents run is going to be endurance. It's all about the optimization, deployment, scaling, what else? Long-term success. Just all those things that are ensure your product is going to be robust, performs well, and can grow with the demand of people using it. So I'll cover walk and run at a high level today, but I want to remind everyone that like each of these topics that Ishrat and I are talking about and have previously talked about could be their own presentations on their own. They truly could. And so this is just a framework that will help you navigate the key steps and considerations in your AI development cycle. Okay, let's get started with our deep dive into walk phase. So building production ready AI. So here we are going to move from prototypes to tools artists can rely on in production. So this is where the magic either starts to pay off, or falls apart. So unlike normal software, AI in pipeline faces unique challenges. Models that never truly feel finished, data that keeps shifting, and that user trust that can vanish after one bad result. So let's start with looking at the key steps for building that production ready AI in our walk phase. So first, there's the development and pipeline integration. This isn't just coding. It's building systems that are going to learn, adapt, and be retrained. So the goal isn't just a model that runs, it's how it fits into Maya, Unreal, or just your studio pipeline so artists and animators can just get real value. So the best practices like version control, code reviews, reproducibility are essential because AI experiments are fragile. Agile methods still apply, but progress is measured not by the features shipped, but by whether the AI supports workflows without breaking them. Okay, so the next thing that we're going to look at in the walk phase is the CI/CD. It's about testing, and evaluation. Traditional software tests aren't going to be enough in AI, okay? So you need evaluate metrics that measure reliable and consistent data. Okay, so it's not just about accuracy. So the CI/CD must include data and model validation and results that aren't simply that pass or fail. You need thresholds, baselines, what else? Just constant checks. So in creative pipelines, a tool that works 9 times out of 10 can still fail if the 10th time breaks the shot, right? So from there, we're going to look at iteration monitoring, auditing, and ML ops. And they are going to take the center stage of this part. Models are retrained and refined on production data, monitored for drift, audited for explainability and compliance, and ML ops is going to automates the retraining and deployment so models are repeatable and reliable. So that's going to keep your AI from being in that like black box that nobody knows and nobody trusts. And finally, the last part of the walk phase is going to be a controlled release. It's going to be real feedback. So you want to start small. Here's the key. So pick your department, pick your production, pick your small game, your indie game, and gathered structured input on the usability, trust, and workflow fit. So that first customer, whether it's rigging, mocap, compositing, whatever, it's often going to be your best teacher, okay? So their feedback is kind of going to harden the tool before it like wider rollout happens. So at that time, at the same time as these steps, these linear steps that we're doing in walk, we just have ongoing considerations that we always need to take into account. The first one is the team structure. So we talked a lot more about that in crawl and detailing, like going through the different roles and stuff, but this is more about working as one. Okay, so you have your ML specialists, your technical directors, technical artists, supervisors, engineers, they all must work together. Artists are going to care about impact, not so much error functions. So communication across the product is key. So teams must balance their research with engineering, exploring models while making them stable for daily use. And sprint reviews and demos aren't just about check-ins. They really, truly are going to build trust in your product with the users and with the company in the studio. Leadership is also equally critical. So AI isn't going to follow traditional milestones. So it's a bit of a mind shift, okay? So if you're used to just doing pure engineering products, then it's different. And these leaders are going to need to be able to balance quick wins with slower grind of research, protect space for experiments, and always tie technical progress back to creative or the business outcomes. And finally, documentation. I know everyone doesn't love documentation, but in this case, it is everything, okay? So data sets, labeling, methods, training runs, what else? Hyperparameters, edge cases. So without this, the knowledge is going to walk out the door with the person who built it. And future retraining risks, you're just gonna risk repeating the same mistakes again if you do not have it documented. Churn is inevitable in every single company, department, industry, honestly, and we need to mitigate that by documenting things. So again, walk is about discipline, iteration, and trust. Get it right, and AI becomes tools artists rely on every day, in-house, and for clients. Get it wrong, and risks become just another experiment that never really made it into use, which is not great. Okay. Walk phase, hard truths. Let's take a step back and look at the corner truths that make AI different from normal software. The things that will determine whether your product really reaches production. First, models are the features in AI. Unlike traditional software where you ship a feature and it's done, AI models are never really finished. So for example, let's take like a denoising AI or something in a VFX pipeline. So it might work well on one shot, but it's going to fail on, but it could fail on a new sequence. So until it's retrained. So that continuous improvement is part of the product itself. The second one is data is going to beat code in AI. So no matter how elegant your algorithm is, if your training data is messy or incomplete, the results are truthfully going to reflect that. So in it, let's take an example. In animation, excuse me, a motion capture cleaning tool might produce jerky or unnatural movements if the data set just isn't include enough diverse motion types. So even if the code is perfect, okay, it's about making sure that we have the right data. And people say this, and I think it's really relevant. So garbage in is garbage out. Third, reproducibility is fragile. So small changes like updating a library, changing a random seed, or adjusting a frame rate can really break yesterday's like perfect results. So in a game pipeline, for example, a character rig AI that performed flawlessly last week, it might suddenly just fail on the new build if dependencies change. So that is why you have to highlight, that's why I'm highlighting controlled environments being essential. And the last is invisible UX. It's everything. Artists and teams care less about model accuracy and more about trust. A tool that works 90% of the time can still destroy confidence if the remaining 10% breaks a critical shot. So for instance, let's take a compositing AI tool that occasionally removes background elements. That's going to cause more rework than doing it manually. So you're quickly eroding that trust with the compositors. These truths aren't just abstract warnings, I promise you, okay? They shape every decision in the walk phase. So understanding them is key, not just for AI itself, but getting buy-in from the artists, the leads, and the executives who will support it in production. Okay, so we're going to talk about in the walk phase securing executive buy-in. This was some of the feedback that Dennis had received, and I think it's really important. And so it's about kind of getting executive buy-in at every phase. So, by the walk phase, we've moved beyond prototypes. AI tools are running in real pipelines, but now we need that executives on board to keep that momentum going. This is where the truths that we discussed, reproducibility, invisible UX, and the fact that models really are never done become critical. First, I need you to show results that matter. So demonstrating the AI in action, speeding up animation retargeting, automating asset tagging, using metrics executives understand, hours saved, fewer errors, faster delivery, more shots. These are all things that is vocabulary that they're going to be aligned with. Second, you're going to emphasize your risk management. This is huge. Walk is where pipelines, testing, and version control take shape. So executives need to see that this discipline prevents costly failures like later down the road or any like hidden costs. Third, highlight the pilot's return on investment. Share adoption numbers, workflow integration, lessons learned from the first team or project. Show how the continued support is going to enable a smooth transition to full-scale deployment in run. So finally, speak in business terms. Translate technical progress into impact on production, quality, or efficiency. Outline the mitigation strategies, migration strategies to executives. Feel confident that the investment is controlled and scalable. So one thing you might be thinking like, oh, that's not really my forte. Like, I don't have the skills. I have the data, I have the technical, but I don't know if I have the soft skills to present it. Grab your artistic buddy that's totally at the company that's invested in this product and have them whip up an awe-expiring PowerPoint template. And then grab your marketing friend and say, hey, like you like this product, let's create some pitches around it. Like you don't have to do this alone, and we're not all good at everything, okay? So utilize the creative and the arts and bridge that gap with the executives. Securing buy-in at this stage isn't just about approval, it's about building trust in AI as a reliable part of the studio's workflow. So that trust sets the foundation for the run phase. And we're going to talk about where we scale these tools across productions and make them indispensable for artists and teams. Run phase, deep dive, production scale AI. Okay, so let's get into the nitty gritty for the run phase. So by this time we've reached the run phase. We have pilots and small releases are performing in real pipelines. The focus is now going to shift for experimentation to endurance, what we talked about, ensuring that AI tools are going to continue to deliver value at scale over time and across production or clients. So run can be thought of in three cornerstones, okay? We have scale, sustain, and support. First, scale. Scaling isn't just about adding more hardware in like a traditional sense. It's about expanding your data pipelines, evaluation metrics, deployment processes so that models remain reliable as the usage grows with them. What else? Automated, reliable, repeatable deployment pipelines are going to allow updates and retraining to happen safely without disrupting the artist workflows, their day-to-day, right? And optimization also matters. So small improvements in render throughput, animation tools, or motion capture processing can have a huge impact at scale. Second, we want to sustain it. AI requires ongoing attention, even after deployments. Models drift, data evolves, uh, teams use the tools in whole totally different ways than you ever envisioned. Sustaining AI means continuous retraining, monitoring, and updating data sets, and maintaining thorough documentation as results remain so you can reproduce it over time. Continuous improvement also plays a role. So gathering feedback, measuring usability, iterating ensures that AI integrates seamlessly into your production workflows. And the last piece of the puzzle, support. Adoption is going to depend on effective support, hands down. For internal tools, this means helping artists and production teams use AI effectively to save time and improve quality. For client-facing products, support includes demos, proof points, and communication to build that trust. So resource planning and budgeting are also critical. Each AI feature has an ongoing maintenance cost, and the value delivered must justify those costs. So in short, Run is about making AI tools reliable, scalable, and sustainable, as we talked about here. This phase sets the stage for the run truth slide that we're going to talk about next, where we're going to explore those unique challenges that determine whether AI sticks in production and delivers that lasting impact. Okay, so now that we've covered our three cornerstones, scale, sustain, and support, let's also take a step back here and reflect on our hard truths for the run phase. Okay, so these aren't just abstract lessons, like I said before for the other one. These shape every decision when your AI is live in a studio pipeline. AI is never finished. Data drifts, user behavior changes constantly. So for example, in an animation studio, let's take a facial motion capture model that worked flawlessly for one character may start failing on new character rigs as the team adds new expressions or rigs. So that continuous monitoring and retraining are going to be essential to just keeping that tool reliable. The scaling illusion. Adding GPUs or cloud instances alone, it's not going to be enough, okay? So in VFX pipeline, automated asset tagging might scale poorly, for example, if your labeling process or validation checks don't keep up. Suddenly you just have like all these hundreds of assets, they're all misclassified, and your tools just becomes this just huge bottleneck instead of the time saver, and then people stop using it, right? This one is huge and could be, again, its own presentation. Ethics hit hard. Okay, so bias, copyright, and misuse are very real at scale, okay? Because we're like out and pushing our product now. And in game development, let's take an example. An AI-generated texture tool might unintentionally reuse a copyrighted pattern from a training data set. One misstep, and you're not only going to halt the whole production, but you could also create very large legal or reputational risks. And the last mile is brutal, or kilometer, as us Canadians say. Going from 80% to 95% reliability often consumes most of the effort. So for instance, in a rendering optimization, a neural, like let's take a neural denoiser might produce acceptable frames for 80% of the shots and tests, but edge cases, what else? Extreme lighting, reflection, smoke, they're going to take a disproportionately long to handle before it's going to be production ready. So you have to keep that in mind. And the last one is every AI feature carries a hidden tax. Each model requires ongoing overhead. So a rigging automation tool may save hours per character, but the retraining it with new rigs, relabeling edge cases, monitoring drifts, and checking metrics adds reoccurring work that accumulates across projects, if not planned for. So launching AI is just the start. Maintaining it is where the real work is, and the discipline that we talked about. And that's exactly why executive buy-ins matter in the run phase. These tools are live in production, and sustained support for leadership is going to need to ensure that these AI tools continue to deliver measurable value and results. So we need to remain reliable at scale and evolve safely over time. So let's talk about how to frame this conversation with executives so that they understand the long-term impact, risks, and return on investment for any AI tools or initiatives that you have going on. Run phase. So this is about sustaining executive support. At the walk phase, executive buy-ins was about proving potential, showing pipelines work, reducing fear, and getting that approval to keep moving forward. So in the run phase, it shifts to proving the staying power of your product. Adoption at scale, responsible governance, and alignment to strategy to executives so the executives feel confident that they want to keep investing. So first, you need to show measurable impact, adoption rates, time saved, fewer errors, faster delivery. These are proof that the AI delivery delivers lasting value. So you should see a trend in this one, okay? It goes through all the different phases, and it's about data, 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 data. The second one is about emphasizing stability and risk management. So drift monitoring, retraining pipelines, ML ops, governance. Executives need to see the scaling is disciplined and it's not risky, right? Like things you feel confident and know you're more likely to do. That goes for everything in life. Third, connect the strategic goals. So the company goals, freeing artists for higher value work internally or differentiation and revenue growth maybe externally. So always tie AI back to your business outcomes, whether it's like KPIs or OKRs or whatever the methodology is your company is using. And finally, stress continuous improvement, feedback, iteration, and executive backing keep the AI trusted, useful, and integrated long term. So run buy-in isn't about the wow factor, okay? I want you to know that. It's about showing that AI can endure and create sustainable value. So one thing I wanted to be clear about too is sometimes executives or department leads want to just skip ahead, okay? They'll say like, why don't we just start at run or walk? Like what's the big deal? So the problem is that AI doesn't work that way. If you try to jump straight into walk or run, you're building your whole thing on quicksand. You don't have that key foundation. You don't have adoption. You don't have trust in the system yet. What happens? The project is going to stall, or worse, it just fails publicly, right? And that sets the whole studio back and not just the initiative. I've seen this firsthand. A studio tried to roll out like an AI-powered animation retiming tool at the walk phase without ever crawling. So no data standards, no small pilot, no clear training for artists. The adoption just flatlined. Support calls piled up. The tools quietly died within 6 months, okay? Not because the idea was bad, but because the groundwork just wasn't there to support it. So that's why nest and crawl are not optional. They de-risk the later stages. They give you the data quality, the infrastructure, and the early wins you need to so that when you get to walk and run, you're not fighting fires, okay? You're building on software ground. And I'm sure you can all relate to this comment of like, can't you just do a new pipeline in like 4 months? Isn't that just possible? It's not possible. It's the exact same thing here, okay? We have to have our foundation set. Okay. So that actually brings us to the end of our 4 phases, okay? So I want to just sort of like a little bit, of a catchphrase. So I want to say we nest to lay the foundation. We crawl to build the momentum. We walk to make the prototypes production ready, and we run to scale and sustain real impact. So whether you're embedding AI inside a studio pipeline or developing a standalone product, these frameworks show the journey from early experiments all the way to trusted, adopted, and delivering lasting values. But success isn't just about following these phases. It also depends on the 3 core pillars that make or break AI in practice. And that is where I'm going to hand it over to Ishrat.
Do you guys hear me okay?
Yes.
Yes, okay. Thank you so much, Christine. So Christine just walked us through the theory, the do's and don'ts. Now, what we're going to do next is take that theory and ground it in something real, okay? And I've been told today's audience is a mix. Many of you are pipeline engineers. Obviously, some of you are VFX artists, AI artists. Some are aspiring AI or machine learning engineers, and a few are also product folks, so a good mix. So let's keep that in mind, and we'll take one of the most common VFX application and see how each of you in your role could contribute to building an AI solution for it. Okay, now when you think about what it takes to build an AI workflow, what do we need? When I ask this question, people actually first think of model architecture, okay? But in fact, the first thing you need is the evaluation metrics. And not just AI metrics, but also the business metrics. And, how do we measure success? How do we convince different stakeholders that this is working, okay? Because you see, when you start thinking about the evaluation metrics, you can start defining the scope of the problem. And that scope, informs the type of data and model architecture that you choose. So the second pillar of the AI is data. And studios are literally sitting on a gold mine of data, but very often that data is not organized and they don't even know what kind of data is useful for what purpose. And we'll talk about all of that in detail. And the third pillar is the model architecture, the brain, okay? There are many different type of models available right now, and it sometimes gets confusing, open sourced, closed sourced, foundational or a pre-trained model these days for Gen AI, some task-specific fine-tuned models. Which model to choose, and where to start? Usually people ask me this question, and my answer here is just take a quick Google search and pick one that people are raging about these days for the task that you are trying to achieve. And why I say this, because as Christine mentioned before, the model is not as important as the data, evaluation metrics, and overall the AI infrastructure. Why? Because you can always exchange the existing model for a newer or better one. And in fact, you should do that, okay? Because this is where the most frequent breakthroughs happen in AI. Every 3 to 6 months, you get a new model. It's breaking all the previous benchmarks. And if your data and evaluation pipelines are robust, you can confidently train this new model, test it, and then replace it with the existing one if it performs better. Okay, so let's review each of these pillars in a bit more detail with an example. Okay, Let's say we are developing an AI tool that removes backgrounds from raw footage, clean actor cutouts, no green screen required. Anyone here who has done rotoscoping knows how painful and time-consuming it is. Now imagine if AI could handle even 70 to 80% of it, that would free up massive artist time. But notice that I have said 70 to 80%, okay? Because no AI solution will ever deliver 100% in wild. Sure, it could hit 100% in a very narrow scope, like a steady, well-lit shot of an actor with short hair and body-fitting costume, etc. And that's why usually the prototype looks so magical in demos, but in production we are dealing with much wider and messier scopes. Okay, and studios that understand this limitation of AI will position AI solution as an augmentation to the manual flow, okay, not a replacement. That way, when the automated pipeline fails, it falls back to the manual one without compromising the overall outputs of the project. And having two workflows side by side also allows you to start running your AI solution in its infancy, when it is in POC stage. Okay, this way AI gets the time to mature, either within your own studio or across the industry, and over time those manual handoffs come fewer and fewer. So what is our goal with the solution is literally to free human artists from repetitive, labor-intensive work, okay? So that they can focus on creative work that really matters. Okay? So let's use this one example, background removal, and walk through the 3 pillars of AI, okay? So let's first talk about evaluation metrics, right? For background removal, the AI performance metrics could be, a pixel or frame accuracy, or model consistency rate, time it takes to remove background for a single image on an average, GPU utilization, memory utilization, etc. Okay. Now here's the thing. Once we move past the prototype stage into walk and run phases, we can't just look at AI performance, okay, in isolation. We need to tie it directly to business impact. So that's where I like to add 2 more categories of evaluation metrics into the mix. One is creative impact, and another is business impact. And depending on what kind of task you are trying to achieve, your creative impact metrics look different. Okay, so for this example, one example that I could give for background removal is quality ratings from supervisors. Now, this is different from simply measuring pixel accuracy. Why? Because pixel accuracy only indicates how many pixels are correctly identified as background or foreground. But from a creative point of view, some pixels are more important than others, okay? And have less error tolerance. For example, pixel near a face of an actor, because as a human, as an audience, we tend to pay more attention to the face and not to any other parts of the body, relatively, okay? So this is a kind of subjective information that the supervisors could bring in the conversation. And then another example of creative impact is the number of artist hours saved, obviously. And this one flows directly into the business impact because, saved hours usually mean also saved cost. But there is also an indirect impact, which is often overlooked. If an artist isn't spending hours cutting backgrounds, they can direct or redirect that energy to something AI can't do well, the more nuanced creative work. Okay, that extra attention and care could improve the overall quality of the project. And as I mentioned before, and also Christine, that not every AI project's intention is to displace VFX artists with AI. It's not. Okay, it's in fact to displace the laborious work hours with creative work hours. Okay, so another metric that we could talk about. So not every AI output will be perfect. Okay, sometimes you'll get partial success. Maybe half the frames look great and the other half don't. So the question is then, can we bridge that gap instead of discarding the AI results and starting completely from scratch, can we import those partial results into our VFX tools so artists only fix what's broken? This, however, requires a substantial amount of pipeline work where we can, import and export AI outputs to desired format of VFX comp tools, Nuke or Maya or whatever you're using for your task. But once that pipeline is ready, we could potentially measure that another key metric. How much time do these partially successful results save compared to doing everything manually? Okay. So these kind of metrics don't just measure success, they help you build intuition about the failure modes in AI and in your user base and in the business and how you can improve them. It informs you about that. So it also is helpful to show the leadership and stakeholders that it's worthwhile to invest more in AI within the studio. Okay, now let's move to the second pillar of AI, data. We have talked about it quite a bit, the unsung hero of AI, okay? When one thinks about the data in AI, the first question we ask is how much data and what kind of data we need. Yeah. And during your nest and crawl phases, I'm sure you have gathered small data set for prototyping and testing. But in the walk and run phases, this data needs to be much larger and well maintained. Okay, so the models that we are training, they learn this complex pattern from the data. More the training examples we give to a model, the better it learns. Now, in established studio, I don't think quantity is a real bottleneck, but let's just assume that you are a new studio and you don't have much data and you still want to, train a really robust model. What do you do? So there's this cool trick that, AI industry uses, and it's called data augmentation. And it's very simple. Instead of feeding the original image 5 times, actually, or feeding it 5 times is the same as 1 time, but it just feels like it's more data. What you could do to increase your data is you can either rotate it or flip it left to right, up and down, scale it, shift the colors, or even add some white noise or something like that. And suddenly you have multiplied your data set without repeating the same images, okay? And this is an essential pre-processing step. And it's one area where pipeline engineers can make a significant impact by building a robust library of data augmentation functions. They are simple Python image processing functions, okay, nothing fancy. But let me ask you, is sheer quantity enough, okay? And the answer is not really. Okay? What we really want in the data set is diversity. Okay? For example, different lighting conditions in your background removal task, you want various camera angles, a mix of backgrounds, either textured or plain backgrounds, genders, races, and ages of actors is diverse. This variety in the data set helps the model experience during training what it would eventually face at the inference time. Okay, so diversity helps models have fewer edge cases. Okay, so let's say your studio has a ton of data. Now, how do we make sure that it is diverse enough? And what I've usually seen people think when they have a lot of data, they just get very confident that, okay, hey, we have worked on many different projects. We should definitely have diverse data. So let's not worry about diversity. Let's just put all of our data into the training pipeline. And this is a big mistake, okay, for 2 reasons. One is that efficiency. You don't want to train for days on GPU cluster and burn through your budget. No, because there is no guarantee that the model you have trained is going to be good on the first try. It's never going to happen. Okay, typically training an AI model is an iterative process. You train your model, test it, it doesn't work well, definitely. You then tweak some parameters, hyperparameters, retrain it, and so on. So it's very iterative, okay? So you want to have short, multiple training iterations to train the model efficiently, okay? And for that, you want curated data that represents the right diversity of scenario. And this is far more valuable than massive unfiltered data set. The second reason you don't want to do it is because of bias. If the same kind of samples or same kind of scenarios are overrepresented, say mostly outdoor shots or mostly one gender, okay, the model will pick up that bias. So let's try to understand why would model do that, okay? So in the supervised learning, in our background removal is a typical supervised learning style of model. So in the supervised learning, you have an input and desired target output that you want the model to learn from the data. Now, the model learns by trying to minimize its prediction error in each training iteration. So it's in a single training iteration, it examines all the input-output pairs and on average attempts to decrease the total error. Now, if the data contains thousands of outdoor scenes and only hundreds of indoor scenes, there's a chance that the model will learn to improve at outdoor scenes because it's cheating, you know. It's trying to figure out a simpler way so that its overall error is low. Okay, so it doesn't want to learn two different things: how to perform well on outdoor and how to perform well on indoors, because indoor scenes are very few. So even if it doesn't perform well on the indoors, right, and there is an error, the amount of error that contributes to that total error will be very little. So it's going to cheat its way. Okay, so that's how the bias is introduced in the model. So curating the data set helps reduce this bias, and increasing variance also then helps you avoid some edge cases that you might, encounter later. So how do you do this curation? Okay, so within the shot, instead of using all the frames, okay, in the shot, what you could do is you can sample unique keyframes. It reduces the number of images for you, but at the same time, it has enough different angles and so on. And to curate different types of shots within the data set, you can use an off-the-shelf data curation solution. These solutions are typically pre-trained AI models. They are trained using some unsupervised training techniques, and they're pretty task agnostic. Okay, I have used one solution called Lightly AI in my past work, and you can look it up. It's really good. So, all right, now here is a practical challenge, okay? What happens when you identify an edge case during the inference time, but you simply don't have a data for it? So now, in the generative AI world, what you could do is you can use synthetic data generation, okay? So you can leverage generative AI to generate images with rain, fog, shadows. Wherever your model is failing, you could, generate some examples, and then you can retrain it. All right, next slide, please. Yeah. So, right, in supervised learning tasks specifically, okay, like our example, background removal, input is only half of the data. The other half is target outputs, or in AI industry often called as ground truth, okay, or annotations, okay? And ground truth isn't only for training. We use it for also evaluation or comparing two models head to head. So here's the key idea. Quantity and diversity that we talked about before of inputs make the model more robust and resilient. Okay, but it's the quality of the ground truth that actually determines how quickly and effectively the model learns during the training. Okay, for example, there are two outdoor scenes. Okay, one has a perfect background mask as a ground truth, and another has some mistakes. Okay, The model will not know which one is right and which one is wrong. For the model, both are right. They are ground truth, right? They're the target. So this adds noise in the training because the model learns neither the correct example nor the bad one. It tries to optimize for both. It tries to compromise for both because it tries to minimize the total error of its prediction. Okay. So anyway, let's be clear. AI models are always prone to errors, always, because it's trying to model or approximate a very complex function. But if your ground truth itself is inconsistent, it leads to worse performance. Okay, as Christine mentioned, garbage in, garbage out, and this is really, really true for ground truth. Okay, you have to be you have to make sure that your ground truth is really high quality. Okay, and to be honest, this is where the studios have a hidden advantage. Okay, you're already producing high quality masks as part of roto and compositing work, but not just for the background removal. For any task, you have an expert. Okay, so those projects artifacts can double as training data basically for free. All the other industry is paying to get their ground truth done and really good money for that. You basically get it for free. In fact, you get it paid for to create those ground truths, and that's amazing. All right, but what if you don't have that luxury, that you are a new studio and you don't have a ground truth? What could you do? What could you do that is not too costly for the studio to create that ground truth? So there are two ways you can do. One is something called bootstrap. It's very common in AI domain to do something like this. So here, this is how it works. So you take a very crappy background removal model, either off the shelf or something that you are working with. It's not working really well. It's crappy, okay? And then you put your inputs in anyway and let it output some bad background mask. Okay. Now you make those imperfect masks and manually polish them. So you have to use your artist to only correct something that's wrong. They might not have to correct it to a production level, just a little bit, so that you can take those output as ground truth and then retrain your model once more. And this time, the model will perform slightly better. So when you give it to your VFX artist, they could, again, very quickly just correct enough so that it's slightly better than what it was before. And you can keep on doing that and bootstrap and get your model better. So while your model is getting better, your ground truth is becoming better too. Okay. Another idea, and this idea might not work for every task, especially for background removal, but it could work. I have seen people using this idea for many other tasks, okay? And it's called synthetic data, right? Where they create some scenarios in Unreal Engine, where the objects and people and everything is already marked. And they would, out of the 3D rendering, take different 2D snapshots to then use it as their ground truth, because in this synthetic data, everything is already annotated and their boundaries and everything is pretty clean. So that's another idea that you could use. But I get it that it's for background removal, it might not be the case, but for some other task, maybe. Okay. Yeah, so the take-home message is have the ground truth quality really high. Next slide, please. All right. Now, we have talked about this quite a bit. Christine has repeatedly, mentioned and conveyed this message that the real challenge in AI isn't training models. It's integrating them. Right? So somebody in my past company, a colleague, used to say that a model without solid data and evaluation pipeline is like owning a sports car without roads to drive on. Okay, it just sits in your garage and costs you money, insurance money. Okay, so it's the same thing. As projects move from can this work, the viability question, right, during the nest and crawl, to can this scale, in run and walk and run phase, your focus shifts. Okay, this is the walk and run phase where you're continuously running models on some project data, finding edge cases, building some small data set to cover those gaps, retraining, checking if the fixes actually work, redeploying, essentially what Christine mentioned as MLOps, okay? It's a cyclic process. And to be honest, one of the biggest headache of MLOps is data handling. All right. So there are some checklists, there are some steps you could take to make sure that that headache never appears again, or at least you are, in a very comfortable, confident position to handle your data when the new data comes in and it keeps on iterating. So the very first step is to have a curation pipeline built. Okay, curate the data and store it, and always store your original data in, so that whenever you have some derivative data on top of it, and that function you find a bug later on or something, you will be able to run that pipeline after the bug is fixed and have that derivative data once more. Okay, so curate your data and store it per task. So your data should be very well divided into different tasks: background removal, de-aging, via rig removal, color correction. Okay, they have to be organized so that when certain ML pipeline tries to pull in, they know where to pull it from. Then the second step is, okay, the footage you get is rarely in an AI-friendly format. And the AI's output rarely fits directly into VFX tools. So that means you need functions to translate both ways, okay, from original to AI ready and back again, production ready. And this is very important. Sometimes people actually, get surprised that, the AI output cannot be ported into the VFX tool, and now we want to fix this in the middle of the project that's going on. So it is really good idea to prepare yourself and not have that, during that kind of a problem arise during the ongoing project. And then the third is you will need to write also the functions of data augmentation in case your data is not large enough. So I would say this is not something that you have to, augment your data and store it somewhere. It's something that happens during the training on the fly. But this is something you need to make sure it goes into your experimentation versioning, that what kind of data augmentation you have used during the training, or whether you use data augmentation or not, because that kind of changes your model and its behavior and its performance altogether. So you will not know, why the model performed good in one experiment and the bad in the other one, without changing anything in the data. It's because of this on-the-fly things that, keep changing your data. So that leads me to the next point, which is dataset versioning, okay? Every time you add new data for edge cases, or you have corrected some faulty ground truth. That happens so many times that we are looking at the experiment results and we are wondering what's wrong, and we find, oh, there is this mistake in the ground truth, and then we ask for a revision on the ground truth, and that goes into the data pipeline. But nobody actually versions that data change, and then we run that experiment and I'm like, what just changed? Why suddenly the model is performing better or worse? Either way. So data set need basically history, just like code does, okay? And finally, the ethical layer. I know this is serious. If you're training on real footage, do you have the rights? Okay, because if you don't have the rights, don't even just kid yourself and try and put that data into the system, because sometimes someone who has put it has forgotten about it, and you are training on it. Okay, you have to anonymize sensitive data if you're allowed to use that data, like faces and those kind of things. Okay, because these questions seem easy to put off until they suddenly stop your deployment cold. So be very careful what data you're allowed to put in your ML pipeline. So in a nutshell, okay, data wins when it's diverse, high quality, ground truth, and well-maintained pipelines. Okay, easy to use workflow. That's the message for this slide, right? Okay. Now this is interesting. This is a bonus slide, and I was deciding whether I should put it or not. So I put this one for anybody who is transitioning from software to AI engineering, because I remember last in the part one, somebody asked me this question: Hey, how do you fine tune a model successfully? Okay, and I know fine tuning is part science, part art. It takes experience to build intuition, but even as a beginner, there are some common patterns to watch if your model is performing well or not. Okay, and because we are talking about background removal as an example, this fine tuning is not related to Gen AI. Okay, it's related to a supervised learning setting, a typical supervised learning setting where you have input and ground truth. Okay. So the key point the message that I want to share here is that don't wait until training is finished to check performance. You need to monitor the model while it's training. Okay, so during the model training, what we usually do, we create 3 data sets. One is training data set, another is validation, and then the test data set. So training data set is typically what the model sees during the training. Okay, that's what it trains on. And then the validation data set is a small amount of data that you keep separate, that the model never sees. You kind of, after each iteration, you check how is model generalizing, and that to see how it's generalizing, you kind of check it on the validation data. And then the test data is similar to validation data. It's bigger than validation data. It's like in the very end when you say, okay, my model is trained, let's test it. That's the data that you use. Or when you want to compare two models head to head, then it's a test data that you evaluate on. Sorry. So based on that, there are 2 errors one should monitor during training. So one is a training error, okay, that measures how well the model is learning the data it's training on, and then the validation error, which measures how well the model going to perform on unseen data after each training iteration. So what to look for here? So if your training error is like going down, okay, but your validation error is saturating or sometimes going up, okay, you have a problem, because this means your model is memorizing the training data. It's almost like it knows for which input image what output image should look like. Okay, it's almost like a hash table, that this is input, this is output, this is input, this is output. Okay, that's not what we want. That's useless. There is nothing, no learning happening. Okay, that's not artificial intelligence. So what should you do? So what is the remedy to when you see something like that happening? So it usually happens when your model is very deep, or it has so many learnable parameters. It has so much capacity that it, in fact, could memorize your data set. Or in other sense, your number of images or number of data points are so small that it could memorize everything. Okay, so whenever that happens, it's called overfitting, that you are fitting too much on your training data. And by increasing either the size of the model, sorry, not increasing the size of the model, increasing the size of the data or decreasing the size of the model could reduce that overfitting. Now, if one is overfitting, there has to be an opposite phenomena, right? It's called underfitting. So when does underfitting happen? It's when neither your training error or your validation error is decreasing. Okay? The model is not learning anything, basically. Okay, and this is like it does not know what's going on. It's just doing some mathematics and some iterations. It just exploring the error function, but it's not really going to a lower error minima of the error function, and that's happens because maybe your training samples are too diverse. So the model is too shallow, or it has not enough learning parameters to capture that model complexity, and then it's very hard for it to learn anything. So either you increase your model size or you decrease the scope of your data. But there is one thing that usually people miss, And that's when you have a really, really messy ground truth. Okay. It's just making the model confused that what exactly am I learning? Because in one example, it says this is the background. In another example, it says, but this is the background. So it's just getting confused. So I would say this is the first thing you should do, that when your model is not training at all, the error is not decreasing, it's underfitting, go check your ground truth. Okay. Okay. This is what I wanted to say. So let's do a wrap up. Next slide, please. All right. We talked about all the pillars in some variable details, data model, evaluation metrics. If I ask you which one is the most important one, the answer should be data. No, I'm kidding. The truth is, none of them works in isolation, okay? The data quality drives model accuracy. The model must evolve as the new data and edge cases emerge. And, metrics it's like a mirror. It keeps telling you, this is wrong, fix this, okay? So it's like a three-way conversation, and it's a cyclic. There is no such thing as when your data is done. Okay, your model architecture is done. Okay, your evaluation done. No such thing. Okay, it keeps on. You have to start with a simplest data set, a basic model, and straightforward metrics. And then you have to keep on, going and improve the complexity of each of these pillars. Okay, the height of each of these pillars. Okay, so AI is not one and done solution. It's a super continuous cycle. All right. Let's think about what happens when you have finished your run phase. Next slide, please. All right. So let's say you have done it. You've built your background removal pipeline. It's live in production, and it's already delivering the return on investment you expected. Yes. Okay. The natural question is, what's next? Well, I would say this is a perfect time to launch your next AI project. All right. And let me give you a head start with an idea. Depending on what we just we're solving, background removal, keeping that in mind, what could be next after background removal, right? So let's say your background removal is working 80% of the time, and that's great. But here's a thought. Before you even send a shot into the pipeline, can you predict whether AI background removal will succeed or fail? And chances are many of you can already do this intuitively, because you look at the shot and think, oh, too much motion blur, that hair is not going to fly, and it will be nightmare. So yeah, we can do that. But that requires a human in the loop. And what if you had an AI pipeline or AI product manager or something that could do that triage for you? So one that looks at the shot and figures out some metadata, steady versus moving camera, texture versus plain background, lights condition, flying hair, loose clothing, whatnot. And then automatically predicts whether your AI background remover can handle it or not. Okay, so think about the impact. As soon as the plates come in during the night, which happens, that's what happens during the night, right? So the AI project manager will send that plate to either manual workflow or AI workflow. And few more human hours are already saved. Everything is set. Next day, when the artists come, they know what shots they're working on. No, decision making is required, and whatever hours you have saved, you can put that invest into mission critical decision making. So, this is the bigger picture here, that you can keep stacking solutions like this one after another, following the same 4 stages we discussed here: nest, crawl, walk, run. Each new project goes through these phases: identifying the problem, exploring ideas, building foundations, developing product-ready tools, scaling them for real impact. And that's how you AI-fy your studio, step by step, project by project, always with business impact in mind. Yes. All right, that's all I wanted to share today. Thank you so much, and I'll give it back to Eric.
Okay. All right. Well, thank you, Ishrat. Thank you, Christine. Very impressive, very comprehensive, and a lot of food for thought. We're now going to switch the session to Q&A. We've been tracking the chat, collecting the questions. I'm sure there'll be more given how informative this session has been. So with that, I'm going to kick it off with the first question. We're going to go a little bit broad, less technical, but I think more about like how you actually get convinced teams to adopt AI. There's a lot of skepticism. AI has gotten a little bit of a black eye in terms of like quality of output, and trustworthiness, reliability. So yeah, I guess generally both of you, I'd love to get kind of a concise take. You both addressed it briefly in your presentations, but how do you convince artists and teams to actually use AI rather than their previous processes or tools because they may not trust the results? Either of
Yeah.
you, Christine.
I'll start. I mean, for me, I think the biggest key to getting artists adapting is to involving them in that process. You have to involve them in the testing so that they feel like they're part of the journey and they feel like they own it. You see it every day, right? If you just bring something in, people are kind of mad about it. But if they feel like it's part of their idea and their buy-in, then they're really going to engage in it. I think the other part is really about delivering value really fast for them. So if it's gonna save artists and animators and composers, whoever, noticeable time without breaking their shot, they're gonna start to use it. And I think the other thing is making it invisible, right? Like just making it part of their tools, not making it a whole thing. Allow them to be creative and take away the administrative. It is a tool, right? So that's, I think, how I've seen it be very successful. I don't know, Ishrat, if you wanted to add anything.
No, that was bang on. I think we need the artist and supervisors and all the creative team into the discussion right in the beginning, when we are, defining our creative impact, what actually, helps them. And that's crucial because they are the users after all. And then if they are finding it as an overhead to their existing pipeline. They need to learn new things and so on while doing the work. And that's not going to fly. So it has to be, as Christine said very aptly, it has to be invisible and it has to be very easy for them to adopt.
Very, very helpful. All right, here's one from the audience, from Jason, I believe. Once the prototype is in place, who is responsible for maintaining the AI workflow in the studio? Do we need a new ML ops team or can existing pipeline engineers handle it?
Yeah, those are good questions. Um, I'm just trying to think here. I mean, it kind of depends on, I think it depends on the size of your studio, first of all. Um, I think that depending on if you are a large studio, a very large studio, you might end up hiring a new team for that. If you're a mid-range studio, I think you're going to sort of transition certain people to handle both. Um, and I think I'm trying to think through my answer here. That's a good question. And I think if you're a small studio, you're going to become a jack of all trades, right? You don't have the luxury to hire a new ML ops. And at some point, somebody has to maintain it. And I think what I have seen work successfully is sometimes passing it back to the pipeline team or whatnot to manage it. I don't know if anyone else has any insight. Those are kind of what I've seen.
Ishrat, any thoughts?
Yeah, I would say maintaining requires more of software engineers as compared to machine learning engineers. So your goal is to just have one and done kind of solution where you're just solving one particular task by AI and that's it. That's going to add some overhead in your cost and a number of people that you're going to hire because you will have to maintain. But if your ultimate goal is to kind of AI-fy your studio slowly, what will happen is that there will be more software engineers or pipeline engineers maintaining your existing run solution while your existing ML team would transition to a new AI project that would be in the nest phase, while also simultaneously supporting maybe 10% of their time to retrain the model or help with that. But usually, once you have your pipelines ready, it doesn't take a lot of ML engineers to maintain it because the retraining, the data updates in your pipeline, evaluation report generation. There are like ton of tools that kind of help you automate the entire MLOps. So it only requires very minimal time to come back and see if something has broken and really in the model, and then you have to, investigate. So that's what I think.
Excellent. All right, going more to convincing the organization to adopt. Have you ever been asked to calculate the cost of developing the AI solution and determine the break-even point with brute force artist work instead? In some context, in VFX, companies seem to brute force with AI artist armies as opposed to developing even regular software development investments. So any tips, softwares, methods for finding this break-even cost point is, I guess, the question.
Okay. Yes. I come from a technical background, so I think I'm a little bit cut and dry on this. But it depends how forward thinking your leadership is. I mean, brute forcing with artists scales linearly. Okay. So, and it gets beyond expensive fast, but AI scales exponentially. So you're freeing artists for creative work and it can pay for itself quicker than you might think. So if you're not, you might fall behind. Yeah. That's where I'm at. I'm a bit cut and dry. I don't know if someone has a softer answer.
Yeah. And it could be not economical or viable for a few more years, couple more years, because all the countries where this work kind of gets offshored, they are upping their hourly rate slowly. But in fact, AI is actually becoming cheaper. Okay. And then there is another thing where whatever you could do with many number of people simultaneously, you would be always be able to do that with AI faster because you will not be able to hire 100 people in a single go and then you say, okay, let's one person do each shot for this and then that's it. You are done. But you can say that to the machines. You can, scale up your cloud and go from 0 to 100, finish every shot in an hour, and then you can scale it down back. So those kind of flexibility that you get with AI is never going to happen with all the human resources and all that kind of bureaucracy that you have to go through, right?
All right, thank you both. Let's see, next question from Jonathan from VFX. What are your ideas or thoughts around building out your ML practice on cloud or local or both?
Cloud or local or both. I think there's a world where it should be both. It was interesting back during COVID to procure machines was really challenging. So that made it more of a challenge, and I think there was more of a push for the cloud. The nice thing about the cloud is you can spin up as you grow. But I think figuring out all the costs can be a challenge and can be shocking if you don't do it right. So I think that you need to have in-house on-prem, like your base amount of computers where sort of that's the lowest you'll dip, or maybe even the average. And then I think spinning it up into the cloud is a good use of, especially for AI. You may not always be using them, right? Only when you're training or running things. So I think for me, it feels like a hybrid of both. But I do think everyone should have their pipeline workable on the cloud for sure, to be able to expand and retract easily.
Yeah, I agree. I think for smaller studios, I would say if you are on-prem, stay on-prem. Okay, don't add more functionality just because everybody else is doing, because being on cloud, as Christine said, only allows you flexibility to have more compute at any given time. That's not really possible very quickly on-prem. But you want to first think about whether you can sustain your growth. So if you are on-prem, just work on-prem, and then slowly, when your model is in the run phase, you are getting return on investment, then you have some cloud engineers into the team, let them make your pipeline for cloud.
I think I might answer this one too, actually. As someone that's been leading an AI studio for the last couple of years, I've actually tasked my technical team with a cloud mitigation strategy, because we're getting sweetheart deals from the cloud providers and the AI providers. So I want to use all of that as much as possible. But I also think we're going to get the Uber, DoorDash price increase in the next 2 or 3 years, and so I want to quickly shift those resources to local or wherever we need to. And so whatever infrastructure we build needs to be portable or somehow mitigate the increase in prices that I think we're about to see. So more of the business lens, not the technical lens, but
That's true.
all right, next question. Yeah, I mean, it's sort of related to what I was just saying. Do you have any tips on how to discuss AI limitations with executives that have some ideas that they might have some ideas that AI can be deployed quickly on wider scopes, or applications that don't even exist yet, that, all the hype really, delivering faster, better, cheaper, right, today, without sounding demeaning or making those questions sound dumb. Right.
Did you want to start, Ishra, or do you want me? I don't know. I don't want to keep going first.
Yeah, I think it's a hard communication. I mean, this question even I had and I have faced that it's not easy to communicate AI in a very easy terms, and it's but that's why I would always say that you try to build your AI solution in such a way that it's parallel to your existing solution, and right at the infancy it gives some kind of return on investment, so that it gets the leadership first, their ears open, that something is happening, and we are getting few dollars, few cents back on the investment. And that's the starting point. As you grow, I think it's very important that you don't skip your crawl run phase. You just add one extra thing, either it's data pipeline, or it's evaluation, and every sprint or every month you kind of have to show one improvement that you are making in terms of money, because that's what they always want to hear. So it going very slow, but giving every sprint or every month some improvement in your report would make them understand, and they have to get literate as well. I mean, it's not like we shouldn't expect that they know everything. So we have to be patient. We have to explain in a business terms that they would get attracted towards this new idea. That's how I would think we should do.
Yeah, no, that's good. And I think just forming it as realistic expectations rather than limitations is going to be key. I don't have anything else to add.
Okay. All right, next up. Okay, looks like this is going back to a previous question about the brute force versus AI. So I'm just trying to decipher it here. More on the previous question, cost of brute force versus AI. I'd say it all depends on the task. Does it take less time to do than to describe, than do it manually? When an artist ask me how to make AI draw this exact 2D shape over a line, I don't know that there's a question there. It's just explaining it out. Dennis, maybe if you can get that rephrased as a question. But then the follow on from Jason, do you have a preference or recommendation for PyTorch versus TensorFlow Keras in VFX work?
Yes, PyTorch. I have a very, very, very strong preference. please use PyTorch. Okay, I elaborate on my answer. So TensorFlow was really good when it came. It was like a sort of pioneer because it started with good chunk of functions that makes ML engineers' life very easy. But PyTorch took over very easily. I think it was 2014 or 13, I don't remember, where Facebook started funding in, and there were some really good engineers. Some of the engineers I also know that worked on PyTorch, who kind of pushed it through and made it fast, very easy to understand. In every aspect, it's better than TensorFlow. So because of that, all of the scientific or academic groups are writing their new models in PyTorch. So let's say you want to plug and play some model from GitHub, and everything else in your infrastructure is TensorFlow. All of your engineers are used to TensorFlow. It will take them some time to read that PyTorch port or PyTorch code or port some of the functions and so on. It's just better to stay in PyTorch. Okay, so I would say very strong opinion I have. Go for PyTorch.
Love that. All right. Final question. This one from Gerard. When evaluating AI models for use cases, you can see, have you found that business executives are okay or comfortable with evaluative subjective measurement, creator satisfaction versus hard objective data, faster execution, increased production per creator? What have you seen as an effective way to evaluate models and convince the execs, I guess?
I think the subjective one is very hard to convince with. That metric is usually so that we capture if our first users, which is VFX artists in the studio and the supervisor and so on, if they are happy using our internal tools and internal product. Also, this one subjective metric that I said, that when you are not necessarily decreasing the amount of hours or cost, but sometimes you are increasing the project quality. And that subjective metric is hard, or it had long-term measurement, because you will only notice that when your existing customer comes back or keeps coming back to you because of that increased quality. So yes, it's hard to convince your leadership, but it is still a really good idea to have that conversation within your colleagues, VFX artists and so on, so that they support the progress and development of this tool.
Yeah. I think just to maybe add that, my experience is executives are always going to lean towards kind of the hard numbers. So they want to hear about like hours saved, fewer revisions, faster delivery, all those kind of things. You really need to connect it to sort of the return on investment. But in our industry, subjectivity really, it matters. It measures it's art, right? And so if the artists don't trust the tool, then they'll just work around it and you'll lose all the value. So I think, as like Ishrat said, it's really is a trick to use both. So showing the quantifiable gains, but also capturing the things like supervisor ratings and supervisor approvals and to get that artist adoption. So I think, I know in our industry you have to do both. But for people that aren't artists, which if they are owners or whatnot, it's like, it's numbers, it's data, it's money.
All right. I think that wraps up our Q&A session. One last reminder before we finish, I want to give another reminder for the Greg Massey presentation. He's the head of CG at Image Engine, which is a part of Cinesight. He will be presenting on October 28th about how to use AI for production insights. And I think with that, we're concluding part 2 of the AI, ML, and VFX animation and game studio pipeline series. The full recording will be made available on YouTube. And so thanks again to Christine and Ishrat for presenting, and to the organizers, Fran, and everyone from the conference. It's been a wonderful session. I hope you've enjoyed it.
Thank you, Eric. This has been fantastic.
Yeah.